guys what I've been working on. This is an extremely lightweight IDE based on Visual Studio Code for XMOS microcontrollers. I am writing an extension for VS Code. First thing I'd like to point out, once the extension is loaded, is you have some new icons down here on the status bar. I do have basic highlighting support for the XC language. So if you have an XC source file in your editor, you'll see that down here that's the language type that's selected. And it's pretty basic right now, no autocomplete or IntelliSense, but maybe we can enhance that over time. The next thing of interest is this JTAG menu. Allows you to target, select which device you want to target. Every attached USB XMOS JTAG adapter should show up here as long as the toolchain supports it. So right now I'm using the XTime Composer 14 toolchain, and that is by the environment variables in terminal from where VS Code was launched. But I can choose a couple different start kits I have attached. This XTAG3 adapter is attached to a XCore 200 Explorer kit. And then you have the simulator XSim as well. So we can go ahead and run this in the simulator. Click the Run button, and you can see the output down here. Hello world. If you want to run a different executable, all you do is go to your executable, right-click, and choose Set Active. And then that's going to set that executable active. You can also flash to a device the executable, but that of course doesn't apply to the simulator. If we try to do that, it says, please choose a JTAG device. We can try running on one of the start kits here. Let's try to run that. Looks like it worked just fine. So now the way you specify the target platform is with this text file. So you want to put a text file in the same folder as your executable, and you want to have it the same file name as the executable _ target.txt. And then the contents of that text file is going to be the target platform. So in this case it's StartKit, but it could be like the XCore 200 Explorer or any of the newer XCore.ai targets would work fine. Of course with the newer toolchain. So that when you click flash, it's going to read this target value out of here. Now for building, I'm actually using a pretty simple make system. I have a make file here that I've created, and it's got paths to a configuration folder, a build folder, which is here, my source folder, which is here, and then where I want to put the binaries once they're compiled, and then the name of the executable. You can customize this as much as you want. I've got placeholders in here for any compiler options, libraries, includes, and so forth. And right now I have a very basic selecting of all the sources that end in these extensions. And I was also playing with some subfolders to make sure that works fine, which it does. And those object files are created in a similar folder structure under build. And then eventually they're compiled over here. So that's what that's all about. The make file is really straightforward, and you can just add additional sources however you like. It depends on two sort of includes, this configure include and then core, and those are both in config up here. The configure include just has like your default compiler options, default libraries. Just consider it like your global defaults. And this is how we pick up the contents of that target file. The core include is where all the magic happens. Don't ask me to explain this. It's pretty crazy, but it works really well. So you don't ever have to mess with that, basically. And this is a sample make file. You just put your make files wherever you want, and you can have multiple projects in your workspace. So I have one here called main. It has its own make file. I could have other projects with their own makefiles. And I could have a parent makefile above all the projects that like builds all the sub-projects. So however you want to arrange it, that's fine. Or if you want to use something other than make. Anyway, that's what I've been working on.